All right, welcome everybody. I'm Emily Ritter. I'm an assistant professor at the University of California, Merced, and I'm the coordinator for the online speakers series for the Peace Science Society International. And this is a new installment of the online Peace Science Colloquium, which we have designed in order to share new peace science research throughout the year, to be able to allow different authors to interact, to present their research, to get feedback from discussants around the country, and to be able to share our work with peace scientists everywhere. So today we have a presentation from Brad Smith of the University of Rochester, and Will Spaniel, who is a postdoc at Stanford University right now, and he's headed to Pittsburgh in the fall. And they're going to do a presentation today on a new measure of nuclear capacity. And today we have discussants who are joining us, including Andrew Coe from the University of Southern California. I have Daniel Hill from the University of Georgia, Matt Fuhrmann from Texas A&M, and then we also have Roseanne McManus joining us from, excuse me, from Baruch University, although I'm still having difficulties adding her to this call, so she's going to join us at some point. And with that, we're going to turn it over to our authors, Will and Brad, who are going to present today their research for 15 minutes, and then we're going to open it up for discussion to the group. If anyone would like to take a look at their paper while they're presenting today, or while we're talking about it, it's online at the Peace Science website under the Colloquia tab, and you should be able to open it there. So with that, Brad and Will, take it away.
Okay, let's see if we can get the screen sharing going again. Okay, so it looks like I'm sharing. And all right, are we all set?
We're good. Go for it.
All right, great. So, so thanks, Emily, for organizing this and inviting us, and thanks to all the discussants and everybody watching online. So today, I'm going to tell you about a little bit about a project William and I have going on right now, where we're measuring the latent nuclear capability of states. And so the end product of the project is a new data set, which we're calling Nuclear. So I'm just going to jump in. So the motivation for this project is that we've known for quite some time the world, there was sort of a sea change in international politics post-1945. And so nuclear weapons and states that possess nuclear weapons are able to shape international outcomes by the virtue of the fact that they can leverage this possession of a nuclear weapon to get things they want. So we've known this for quite some time, and a number of theoretical and empirical studies have sort of confirmed this. But lately, scholarship has turned to focusing on the fact that the capability to build a nuclear weapon is also very important for shaping international outcomes. And we can see this in a number of recent studies, and also in the news in the recent Iran nuclear deal. And so sort of a difficulty that each of the studies that have turned to this have come across and dealt with in various ways is that while it's fairly straightforward to measure the possession of a weapon with just a 0 or 1 indicator, this capability to build a weapon, because it's inherently unobservable, is not so straightforward to measure. And so the existing studies have sort of all used a common approach where they collect a series of indicators on activities that are theoretically related to the production of nuclear weapons, like the capability to produce explosives or electricity or uranium enrichment and things of this nature, and then code a number of 0, 1 indicators and sum across them to produce an additive index. And so there are some implicit assumptions that go into this, like that the weighting of each of these activities should be equal in the index and things of this nature that sort of limit its flexibility. And our contribution here is that we're going to be utilizing an item response framework to estimate this unobserved capability directly and do this in a more flexible way than the additive index approach. And so really the goal here is to let the data speak and estimate capability as well as the relative characteristics of each of these activities simultaneously. So we're just going to let the statistical model tell us what the relative weighting and importance of each of these activities is. Additionally, because we're going to estimate this in a Bayesian framework, this gives us a really straightforward way to model the uncertainty that's inherent in measuring an unobserved quantity of interest. And so the posterior density is going to let us do nice things like bootstrap and things like that to account for this uncertainty. So with that, I'll turn to a description of the model. So the goal is to estimate unobservable capability from observable behavior. And luckily for us, there's a long tradition which started in the psychology literature known as item response theory that should be familiar to political scientists because this framework has sort of been used to study legislative roll call voting, voting in the UN, and things of this nature. And this really, this approach fits the problem that we identify really well. Because it's designed to measure these unobservable quantities of interest based on observable behavior. So what we're going to do is, just like in the educational testing literature where this approach has been used, we're going to treat these observed indicators as test questions. And the approach is going to allow us to let the difficulty and importance of each indicator to vary. And when I talk about the parameters on the next slide, I'll be a little more specific about how we do this. So we're using a very standard 3-parameter item response model that's been used in a number of studies. This is nothing new. And so we're trying to use the simplest possible model to capture what's going on in the data. So we're going to estimate 3 parameters. So the first parameter we call new. And this is our primary parameter of interest. It's going to capture the unobserved latent nuclear capability of state I in year T. As new increases, a state becomes more likely to participate in each activity. As new decreases, states become less likely. The other 2 parameters are going to let the relative importance of each activity that we use as data to float. So alpha is going to capture the difficulty. And so to go back to our testing, our educational testing analogy, so alpha is going to capture the fact that if we were wanting to find out a student's unobservable math ability, simple addition and computation problems are going to be much less difficult than problems on calculus problems, for example. Beta, similarly, is going to describe the discrimination of activity K. And so what this is going to do is parameterize the degree to which success or failure is related to the underlying dimension that we're measuring in terms of new. And so this is going to pick up on the fact that, to go back to our analogy, that if we place a literature question, a reading comprehension question, on a math exam, a student's performance on this literature question would not really tell us much about their math ability. So here we can see, as this visual describes alpha's effect on the response. So you can see along the x-axis, as new increases, the probability of success becomes higher. And alpha basically just parameterizes where this curve is going to cross the line 0.5. Similarly, we have beta here. And so we can see that at the extreme where beta is equal to 0, this light blue line, new has the capability measure has no relationship to success or failure on a given item. And then as we increase beta, this distinction between high capability and low capability states becomes much more sharp. And so what both of these alpha and beta parameters are going to do for each activity is allow us to get at this appropriate weighting scheme so that we don't read too much into certain activities and then not enough into others. And this is also going to produce estimates that are of themselves going to be interesting. So with this, I'll turn to the data. So we have data from 3 sources. And so the first is going to be we're going to use the components of the index utilized by Joe and Gartsky in their 2007 study. So these are things like uranium possession, nitric production, all activities that are related to the production of nuclear weapons. Then we're going to use data on uranium enrichment and reprocessing facilities from Fuhrmann and Koch's recent study. And in addition to this, we've self-coded a number of measures that we're going to include in estimation of the model. Heavy water and non-heavy water civilian power plants, whether or not a state in a given year has built a nuclear submarine or possesses a nuclear submarine, and then finally data on nuclear weapons tests. So Because we have a large number of parameters, we're going to estimate this in a Bayesian framework using Hamiltonian Monte Carlo, which is implemented in the Stan language in RStan. We're going to do standard normalizations to sort of fix the scale, location, direction of everything that I'm happy to talk about in the discussion Q&A. And then we're going to use 3 parallel chains, each with 10,000 draws after a 5,000 draw burn-in period. And all of the convergence diagnostics that we looked at looked great. And so I'm happy to talk about all the specifics of estimation in the discussion as well. So with that, I'll turn to the results. I'm going to give a brief overview of our results. So first, I'm going to talk a little bit about face validity and show you how our estimates pick up on features and patterns in the data that we should expect given previous scholarship. Then I'm going to give a more explicit comparison between our results and the results of the additive index of Joe and Gartsky and show how we pick up on some meaningful nuances in the data generating process that suggest that we're actually picking up on something interesting here versus the implicit assumptions of the additive index. And we're getting a more full picture of nuclear capability. And then finally, I'll talk very briefly about how you can use these scores to replicate and assess the robustness of existing findings and how we can make sure that we're not getting results that are induced by over-precision. So first, if you look at this map of the world, note that in 2001, nuclear capability is fairly high. And so given this, this is sort of a pattern that nuclear scholars have noticed, that is that worldwide capabilities have increased dramatically since 1945. The natural question to ask is whether or not we ought to expect, given this, a rise in proliferation, a rise in states building additional nuclear weapons. And so to test this, sort of visually get a feel for this and what our data say about it, we plot here along the light blue line the number of nuclear states in a given year. The dark blue line and the confidence band around it counts the number of states which we measure as potential proliferators. And so the way we do this is we take North Korea's score in 2001, a state that was 5 years away from a successful test, and we count in a given year the number of states with a capability estimate higher than this. And then to get this confidence interval, we just simulate from the posterior and take these counts and plot a 95% confidence interval. And what we find is that, consistent with existing arguments, the number of potential proliferators has not, the number of nuclear states has not tracked closely with the number of potential proliferators. And so, of note here, we actually find a very strong effect. So the number of potential proliferators under our measure is significantly greater than in other studies, such as the one that due to Hyman's. So this sort of gives face validity and shows that we pick up on some known patterns. Next, I'll show that, so if you compare our estimates to those of Joe and Gartsky, you can see that within each category of the additive index, there's a large amount of variation. So in particular, turn your attention to sort of estimates between 3 and 6. And so you can see that if you compare 3 to 4, 4 to 5, 5 to 6, there's a large amount of overlap. So a number of states that are assigned to 5 under Joe and Gartsky's index, we estimate to have higher capability than states given a 6 or a 7. And so what this suggests is that there is real variation in the importance of each of these activities. Some activities are more difficult than others. Some activities tell us more about underlying capability than others. So we're picking up on this variation that's lost in the additive index and its equal weighting of activities. It's worth noting that we do have some things in our model that Joe and Gartsky don't have in theirs, and we've re-estimated this with only the Joe and Gartsky indicators, and it produces a very similar plot with lots of overlap, and that's in an appendix that I don't think is attached to the paper that we sent out, but I'm happy to talk about that in discussion. So next, for some more specific comparisons, sort of zooming in on how we're able to pick up on these nuances, you can see that from 1962 to 1970, we're actually able to separate out between the US and Israel, where Joe and Gartsky assigned them the same score. And so this is, again, due to these weightings that we can actually separate out the relative importance of each of these characteristics. And then in other cases, we demonstrate that the picture is not so clear. And so the additive index sometimes assigns a clear rank ordering between two states when our estimates suggest that their confidence intervals are going to overlap, and it's going to be less clear which state is more capable in a given year. Okay. So finally, we can use these scores for replication and robustness checks on existing work. And so in the paper, we discuss this more in depth, but we use our estimates of new to assess these empirical results using latency as an independent variable. And we
2 minutes, Brad.
Okay, thank you. We demonstrate that some findings are robust to this and others don't hold. And in particular, what we do here to assess this robustness is that because we have a full posterior density across our estimates of new, we bootstrap the entire process to account for its estimation uncertainty. And this gives us assurance that we're not drawing conclusions based on over-precision because of these additive indices that don't take into account that we're measuring something that's not directly observable, and there's uncertainty inherent in that process. So with that, I'll conclude. We've provided a new data set on nuclear weapons capability. I've argued that our estimates, which we call new of nuclear capability, has theoretical and substantive advantages over these additive indices, in large part because of the flexibility of this 3-parameter item response setup that we utilize. Something I did not discuss in the presentation, but that is a useful byproduct is that the alpha and beta parameters actually give us estimates of the relative importance of these nuclear activities. And so that we can actually speak to topics that have been debated in the literature on nuclear proliferation. We're working now on providing a package to re-estimate new. So I think William and I both have the opinion that this should be a living project, and that even after we're sort of done with it, we want it to be able to incorporate new data collection efforts. And so if a new set of indicators becomes available, we want it to be very straightforward to provide, to sort of feed in a properly formatted data set and let it go for a little while, and it will pop out new estimates of new, and also to be as transparent as possible so that it's clear how given indicators fit into our scheme. And then finally, we're both excited about this project, and we hope everyone will keep an eye out because they'll be posted online very soon for people to use in empirical studies of nuclear proliferation. So with that, thank you, and I look forward to your comments.
Perfect timing. So with that, I'll open it up to our discussants. And as I mentioned earlier, we generally like for this to be kind of conversational. So if you have a comment, raise to get us started, then we'll let everybody respond. We'll start with Matt.
Oh, shoot.
Great, thanks. Well, first I just want to say to Brad and Will, I really enjoyed reading the paper, and I think you guys are onto something really interesting and important here. I thought I might just kick things off by maybe asking you for more clarity on what you mean by nuclear capability. And in particular, I was a little surprised that you included nuclear weapons possession and nuclear testing in your measure, along with other things that are normally thought of as having a latent or unobserved nuclear weapons capability. So it's I guess what I really want to know is what are the implications of combining these two things into a single measure? And once you do that, I'm not sure we can really call this a measure of nuclear latency per se. So I'd just be curious to hear your thoughts on what you think you're tapping into, because this to me has implications for framing and also for the analysis and the inferences you can draw from the findings.
Okay. So I think that's the point is well taken. So we've actually we've gotten similar feedback recently, and so I guess the one response is that we believe that your capability is related to whether or not you actually possess a weapon and whether or not you've successfully tested a weapon. And so along that dimension, the possession of a weapon provides us with information about your latent capability. So the more practical, I guess, response is that we are in the process now of re-estimating everything with those omitted for a number of reasons. And so the preliminary stuff that we have, nothing is different. in terms of all of the plots and everything I presented and the results that we find. But yeah, I think that's definitely something that we need to focus on carefully as we, refine the framing. So, William, I don't know if you have a.
I've got a follow-up from Danny first. Okay, Will, and then we'll take Danny.
I only have 2 sentences. The one other thing that I have to add is that there are some studies out there that will also tell you that it's not just having a nuclear weapon, but your ability to produce more of them and your ability to do that very quickly and efficiently. And so it's important to not only think about one's latent capability of building a weapon, but even if you've already built a weapon, how capable are you of continuing to do that and in large quantities and relatively quickly?
Danny?
Sure. So I would add, if that is your concept, I would make that clear in the paper, that it's sort of the ability to produce more rather than the ability to produce any.
Okay.
Because I will add that this is not sort of my substantive area of expertise. I was brought in more for the modeling. But it seems to me that the usefulness of an indicator of latent capability, right? I think Matt's right that some of this directly indicates the existence of a nuclear, program or the possession of nuclear weapons. So it seems a little strange to call it latent, but I would think the usefulness of that would be in predicting which countries that do not currently have a nuclear program or a nuclear weapon are likely to acquire one in the future, right? So if I were you, I would go with the more recent version of the model you've estimated that's excluded those items. This is especially a problem for your replication of Joe and Gartsky, where it seems to me that you have included information about the outcome variable there in your index, right?
Right.
So I'd want to see that you would still be able to predict those things reasonably well when you've excluded those items from the model. The estimates, that you report in the paper suggest that, assuming the latent variable estimates themselves don't change much, you will be able to predict those items reasonably well. So it shouldn't be an issue. But yeah, I agree with Matt's comments there.
Roseanne. Welcome. I'm so glad that we worked it out that you could be on.
Yes, I'm glad to be joining the program. I thought I would just jump in because I was also going to make a similar comment, and I was just thinking of the parallel to psychological research, which is, I guess, where this idea of the item response theory developed. And usually, if you had some sort of personality test, you would have all these different questions that measured personality, but you wouldn't actually have the actual measure of, introversion or extroversion in there because that's unmeasurable. But these variables that you have, actually conducting a nuclear test, actually possessing nuclear weapons, that seems like almost too much of a direct measure to be including in this type of model, if that makes sense.
I have 2 fingers from Andrew, and then we'll let the authors respond.
So I agree with much of what's been said so far. I think to the extent you want to convince the reader that this is the right measure of nuclear latency, you need somewhere in the paper to say this, from a theoretical perspective, is what we're going to use as the definition of latency, so that we can convince you that this statistical black box is producing something that is a good measure of that theoretical concept. As it stands, it's very hard to know why or if IRT is the appropriate framework here. Is this, so for instance, if I think to the papers that talk about nuclear latency or that think about whether some state might go nuclear in the future, they usually talk about nuclear capability as, suppose that this state decided today to pursue nuclear weapons, how many years would it be until they get them? And so there's 2 kind of important components of that definition. One is how many years is it going to be? So the measure of how good they are is like, is it going to take 5 years? Is it going to take 20 years? And the second is that it supposes that they have decided to do so. So it's a little strange that you have a single measure which tells you something about the nuclear latency of a country like North Korea, which over most of the data set is trying hard to get nuclear weapons, and that is also comparable to Japan, a measure for Japan where over most of the period they're not attempting to get nuclear weapons at all. Right? So it seems like your statistical model assumes that the way these indicators work is that every state is trying to get every indicator at all points in time. And that's plainly not true for some cases, at least like Japan and many of the other countries in the data set are not attempting to get nuclear weapons. So it's not clear that you can take whether they have this capability currently as an indication of their latency.
You guys want to take that?
Yeah, so I think so. The point you raised, Andrew, is really good. So it's certainly the case that what we have estimated is some combination of the two, right? How hard you're trying and how effective your efforts are. And so I guess this is not. I mean, this is not explicit in the paper, and it's certainly something we need to think about more. I'm curious to see what you guys think about the idea that. So to go back to the educational testing analogy. If the goal is to find out which students are best at solving some sort of problem, I suppose this would not be able to pick up on which students are studying hard versus which students have innate ability. And so, insofar as that analogy is relevant, if the question is which states at a particular time can proliferate, or what's the time to proliferation? I'm not sure how meaningful that distinction is in terms of sort of questions that you might be interested in using this as like an independent variable for. And also I guess we've thought about a little bit how you might be able to model this and William and I haven't come up with anything good yet. William, do you have?
But the discrimination parameter takes care of some of those concerns?
To some extent, it does. I mean, in just that if there's states that have a high capability and aren't taking, these steps, the discrimination parameter sort of gives us noise there. But it's across all states, and so you're getting sort of this average effect, which is not addressing the point that Andrew brought up about, there being sort of two dimensions that are relevant here.
Matt.
Yeah, just to kind of follow up on some of these points. I think the issue that Andrew raised about time is also really critical, because most of the time when we talk about nuclear latency, we're talking about being a screwdriver's turn away from a nuclear bomb, so to speak. So you can think about a case like Japan. But we can also imagine a different conception of nuclear capability or nuclear latency where our time horizon's a little bit longer. And it seems like maybe that's what you guys are talking about, rather than latency per se. So if we look at your graph where you show the number of nuclear capable states, it was about 70 states at the end of 2001, which if we're using the screwdriver's turn away conception of latency, I find frankly a little bit hard to believe.
That's terrifying.
But if it's these are the list of countries that could do it if given 15 years,
mm-hmm.
then I'm more likely to buy into that kind of framework. And so I think this goes back to how you guys are conceiving about nuclear capability and what that means, and just being very clear. I think a lot of these issues will just go away if you can just clarify what you want to study and why you think that conception of it is theoretically appropriate. But I think, yeah, a lot of what's come up today, I think, could be traced back to that general point so far.
Talk about how we created that graph.
Sorry, what you were breaking up a little bit.
I don't think in the presentation we discussed how the graph was created, like the data generating process for that. So that might be a good thing to discuss.
Oh, the potential proliferator.
Yeah.
Oh, yeah. So the way we get the potential proliferators line is taking North Korea's score in 2001 and then counting the number of states in a given year. So we're making this 1946 to 2001 North Korea comparison. So that's the way that's created. So you could imagine a number of different ways of calculating the number of potential proliferators. But then this gets to your question of, is this what exactly is it that we're picking up on? Which I think you're exactly right. We need to be much more clear about that.
Well, in particular, what are you trying to pick up on, and then is this an appropriate measure?
Right. So I think the initial way that we conceived of it is this idea of if a state decided today to build a nuclear weapon, based on their effort and ability today, how long would it take them? And this being a measure of that. And we haven't been clear enough about that, I think, in the paper.
In addressing Emily's concern that this is like a really scary thing, I actually find that this to be relatively reassuring, that there have been that many states for that long. If you look at the graph, it's not anything new in terms of how many, like dozens and dozens of states that have that capability to build a weapon and haven't. And so I find this reassuring because if we think about how this graph is going to trend over time, we're only going to have more states being more and more capable. And it seems that that's not going to necessarily result in a large jump in states that actually develop these nuclear weapons.
So it means that your concept is about capacity and not willingness, right? So like what Andrew said earlier about that you're choosing to, you're not only capable, but you're going to. So Andrew's got 2 fingers, and I should stop talking since I haven't read the paper.
So just a quick suggestion for how to deal with this sort of question. Well, 2 suggestions. The first one is to ask, is it possible when you run the estimation to separate the population of state years into those state years where we think that the state is actually trying to get nuclear weapons, and those state years in which we think the state in that year is not trying to get nuclear weapons, and to see how the estimates of difficulty and relevance and latency differ across those 2 subsets of state years. To the extent that they don't differ, then it's going to turn out that, hey, trying to get nuclear weapons actually isn't that important for measuring latency. If they differ, then you've learned things about how you can adjust the estimates for the fact that we can measure states' capabilities across all state years, but we control for the fact sort of that some of them are actually trying to get these things and some of them are merely achieving these things as a result of some other purpose. The second suggestion is, one way to look at this is that, in practice, there are some estimates out there of, for this country in this year, this is how long the CIA thinks it's going to be until they get nuclear weapons. You have this for a bunch of countries, like Alex Montgomery and Adam Mount's paper records all these estimates from over the course of the Cold War of lots of different countries. So you could take those and compare them to what your model spits out as its estimate of latency. So is it true that there's a strong, like what we'd like to see is a strong correlation between what your model says is the country's latency and what the CIA says is the number of years away from a program they are. You can also do this with looking at, for the countries that end up getting nuclear weapons, you know that in each year the actual amount of time until they get nuclear weapons. And you could again see if it actually correlates with your latency measure and what kind of outliers or deviant cases there are. That might be very interesting.
Okay.
I've got 2 fingers from Roseanne.
Yes. This capability of the question of capability versus willingness, which the last couple of people have brought up, I also was going to mention as being important, because it does seem to me that in some cases, some of these technologies in your measure, it might not be that the country is not capable of doing them. Maybe it could do them if it wanted to, but it just doesn't feel any need to because of the fact that it's not producing nuclear weapons. So there's 2 complicated things going on at once.
Brad or Will? You guys good?
Yeah, I think
Yeah.
the point is very well taken. I think that's definitely something that needs to be addressed. Yeah, that's.
Danny.
So I really love your discussion of the problem with additive indices. This is kind of a hobby horse of mine. So I am an easy sell here. But I think if you want to sort of sell the approach to people who are maybe not as keen on it as I am, I would actually, I mean, I know you need to present the details of your model, and it's all very clear and transparent. But I would actually spend a little less time sort of discussing the origins of item response theory modeling and sort of how these things work. I mean, effectively, right, the discrimination and difficulty parameters work the same way a coefficient and an intercept do in a logit model, right? And so I think most people can probably pick up on that pretty easily. I think if you want to get to more of why this is useful sort of substantively, you could really play up, I think, the policy consequences of using these additive indices that effectively assume no measurement error, right? So, I mean, you could think about this sort of in terms of false positives or false negatives, right? Sort of conducting, say, a military strike against a country that sort of has a, you know, in reality, a lower level of latency than we think they do, or failing to do something when a country has a sort of higher level of latency when we think they do. Because these additive indices sort of assume, you know, you have your United Kingdom, Israel, or UK, France, and Israel, US examples. Right, that additive index assumes that Israel and the United States are the same sort of probability 1, right? Your model can provide estimates of the probabilities that sort of two countries are different or that two countries are the same, which allow you to very nicely quantify this uncertainty in the measure, right? And I think playing up that and sort of, again, talking about the policy consequences of using these indices that effectively assume countries are the same, right? I mean, I use this and work on human rights, where human rights indices are sometimes used to make decisions about, say, foreign aid allocation. So there are very real consequences to underestimating or overestimating a country's human rights performance. Something like nuclear weapons, it seems like this is an area where the consequences really could not be more dire, right? So I think the ability to account for measurement error is sort of the crucial contribution here, and you could do a bit more to discuss that. Keith Schnackenberg and Chris Ferris have a paper in PSRM from 2014 where they do a good job discussing and presenting sort of those kind of results. So you might look to that paper for an example of that.
Matt.
I just wanted to echo Danny's points because I jotted down the same thing as I was reading the paper. I think there's an opportunity here to tap into broader methodological debates in the discipline about indices. So another thing you might look at is the debate about the Pauly measure. Trier and Jackman had that paper in the AJPS. I don't remember when, but maybe 5-6 years ago, where they were pointing out some of the problems with that measure of democracy based on that on the index. So to the extent you guys want to broaden this out a little bit and make more of a general methodological point, I think the opportunity is there to potentially do so.
Questions a lot.
Yeah.
Matt?
Well, I hesitate to dive into the weeds, but I almost can't resist.
And then I see Andrew.
But I think I wondered why certain indicators were included while others were not. So, for example, I like the inclusion of submarines, but why not include other delivery systems if you're going to include submarines? Similarly, I wondered about, I know you guys are trying to build on the Joe Gardsky and Meyer and Stoll approach here, but in some ways, some of the indicators that they came up with don't seem intuitively obvious to me as things we'd want to look at if our goal was to measure nuclear capability. Like, I was pretty surprised that nitric production performed so well in the discrimination analysis. This just measures whether a country has developed non-organic fertilizer. And so I'm like having a really hard time figuring out what that's picking up. And I know you guys are very clear that you're saying this is just the first cut. There are opportunities to add to this, and other scholars should do so. But I also think it's worth spending some more time really thinking carefully about what the best indicators are. And just real quick related to that, some of these categories could potentially be combined. For example, I didn't know why you would want a separate indicator for reprocessing and enrichment, because they're essentially substitutes in that all you need to do to make a bomb is to get the fissile material. It could be either weapons-grade HEU or plutonium. You only need one or the other. So I guess an alternative way to go with that would just be to do one indicator rather than two. So I realize these are kind of very specific technical points, but I wondered if you thought more about potentially modifying what's going into the model in terms of your metrics.
I have 2 fingers from Danny and then 1 finger from Andrew.
Yeah, I was just following up on Matt's comment. This is a pretty specific thing, but I also noticed you talked about chemical capability and nitric production as something that could be informative because it has a large discrimination parameter, but it also has a low difficulty parameter, right? So that means even states at very low levels of capability are likely to have those attributes, so I don't know how informative it could really be. I mean, even if states that exceed the threshold are very likely to do it, almost everyone exceeds the threshold, right? So that curve is sort of shifted so far to the left that everyone has a very high probability, and thus everyone is likely doing it. And so it's probably not that informative. That's all.
You guys want to hit this or turn to Andrew?
Yeah, just really quickly, I think William might have more insight on different combinations of indicators, because I think he's a little more familiar with the process and what goes into building a nuclear weapon than I am. But I think our sort of approach, which is probably apparent, was let's throw everything in here for the, everything we have and see what sticks. And I think I was sort of struck. I agree. I was struck by the high discrimination parameters on nitric production and things like that. And I think this really, to me, I think the most sensible explanation for this is that you have these low difficulty, and this is really picking up on what you mentioned earlier, that there's these 2 dimensions here, right? It's how hard you're trying and how effective you are. And so these, nitric production is not particularly difficult, but we only really see the states that are trying do it, and this is a potential explanation. So William, do you have?
One thing that I would say on, 2 points. One, if you are aware of other ways that we could capture more data on, say, those delivery mechanisms, we would love to be able to include those. This is what I could figure out that we could get or could work to get, given that there was data available. So, for example, like we found some good pamphlets from the IAEA, which had a long list of civilian plants for both heavy water reactors and non-heavy water reactors. So we could go through those and make sure that it was rigorous and we were getting the data right for those. So if you're aware of other ways that we could acquire that sort of data, whether it's raw or already processed for us, we'd love to be able to include that. And thinking about having both enrichment and reprocessing, having both of those in there would allow us to pick up on the fact that if you're capable of doing both, you should be more, in this nuclear measure, you should be a stronger latent nuclear state than a country that can only do one or the other or neither.
Okay, let's take Andrew's point.
So first, a quick follow-up on Matt's point, and then a new one. So the follow-up is to ask, there's sort of another attempt to use a non-parametric statistical method to try to understand how a bunch of indicators we think matter combine into a single measure of how likely a state is going to be able to get nuclear weapons. I'm talking about Alex Lonoshka and Rex Douglas's paper. And their approach is put in everything. So, I mean, I don't know how many total variables they use, but it's more than 15. And it includes things that are, measures of industrial capacity more generally, GDP per capita, all of this other stuff. So, it'd be nice to have even though that paper's not published yet, it's sort of been distributed. it'd be nice to have some sort of discussion in the paper of like, what is the main difference in your approach, and like why is your approach more appropriate for some things or better generally than just stuffing in everything. And the second is to ask, so these 15 indicators that you use, they're all things which seem directly relevant to getting nuclear weapons. On the other hand, they're things which often come in a sequence. So having a reprocessing plant doesn't make much sense unless you have a reactor that's going to produce separable plutonium. You know, having a centrifuge enrichment plant doesn't make much sense unless unless you already have uranium mines and can process it into gas and so on. So many of these indicators are dependent on each other in the sense that you can't have one until you have the previous one. And so that for each of these, there's a sequence that corresponds to the plutonium path to a bomb and another sequence that corresponds to the uranium path to a bomb. And it seems to me that your statistical model assumes these things are all independent of each other. So once you tell me what nu is, I don't need to know what the other indicators are to know what your probability of getting this indicator in this year is. So I wonder, you know, bearing in mind Emily's injunction to stay away from this is the paper you ought to have written rather than the paper you should have, maybe if you guys keep working on this project, like this is something to think about for the follow-on paper in which you try to adapt the model to take account of the fact that these things seem to come in a sequence rather than all being done independently of each other.
Brad or Will?
Yeah, I mean, I agree. This is something that ideally the model could speak to, because it's, you know, it's fairly clear that the local independence assumption is not really, you know, totally plausible for all of these. And so we actually, in earlier, we actually have a little bit richer of a data set in that we have indicators for various types of enrichment, or maybe was it reprocessing, William?
It's enrichment.
It's right. So
it's from Matt's data set.
Yeah, and so we used these, and so the problem here is that the local independence problem really bites there, and so convergence was a serious issue because if you have one, there's no reason to have the others. So you have all these capable states, and so this is an issue. And we've thought about doing some sort of sequential model too, and just yeah, that's certainly something that we need to think about. Thanks for this.
Emailing Rex over the last few days, so I will email him that question and see what he thinks and see what he suggests. Thanks for bringing that up.
Danny.
Yes, so this is sort of a follow-up, but also an additional point. I would have to look into it, but I mean, I believe in the Bayesian framework there should be some way to allow for a correlation among the items themselves that does not come from the latent trait. So that would be one way of dealing with the local independence assumption, or the fact that you're likely violating it here. Another thing is that the way you set the model up assumes that sort of a state's latent capability is sort of independent across time, right? That its capability at time t is independent of its capability at time t minus 1. Kevin Quinn and then some others have done some interesting work with these dynamic item response models. And I mean, I think that can be theoretically motivated here, right? These things require industrial infrastructure that's difficult to build in the first place. Once it's there, it's likely to stick around, so you probably have a lot of persistence there. And so you can use a random walk prior for the latent trait, which is actually not terribly difficult to set up. You can look at the Quinn 2002 paper in Political Analysis. You just have, I mean, it's the same way you have it now for the first time period, and then in subsequent time periods, it's a normal distribution with a mean that is just the previous value of the latent trait and some variance parameter you estimate from the data. So I think that would be useful here as well.
Yeah, so for Danny's point, I feel like this has been my response to half the things. But so in an earlier, so before we got data that went outside of Joe and Gartsky's, we had a dynamic version of the model, and so I haven't gotten it to play nice with all of the data yet for some reason that eludes me. But another thing that was nice about this is that it really smoothed everything out, and this lumpiness that you get within these categories when you compare it to the index is sort of gone. So no, that's something that hopefully can be incorporated. And
I have an open queue.
I could follow up on that with one more sort of method Z point, since that's why I'm here, I guess. And it is that you guys do a really good job of graphically presenting your results. And then you have these tables where you report the difficulty and discrimination parameters. And it seems to me that it would be useful there just to have a rope ladder plot, right, where you sort them, right, in ascending order. And then it would be very easy to sort of see, because I kept going back to the table, back and forth between the table and text. You say sort of a discrimination parameter is sort of in the middle range. But when they're not sorted and presented graphically, it's difficult to see that. That would make it very easy to see which things are larger than others, whether the confidence or credible intervals overlap for different items, and that kind of thing. So that would be useful too.
Yeah, thanks.
Andrew?
I wanted to talk about the last part of the paper where you guys are sort of going through some exercises to try to demonstrate the value of the new measure. So in the spirit of always demanding more of everything, it seemed to me like some of that stuff was very interesting, but you sort of let it just hang and moved on. Like, for instance, it's very counterintuitive that having a heavy water reactor civilian power plant is more difficult than having a nuclear submarine. I mean, if I just think about the stuff that goes into building each of those things, I mean, the nuclear submarine is like a miniaturized version of the other, so along with a bunch of other difficult things. So I think it would help, when you mention this surprising result that comes out and then you don't offer any explanation for it, I don't know whether to assume that they discovered something really strange, this is something we should think about, or this is some anomaly that the model is producing because there's something wrong with the model.
Right.
So, I think thinking more about these things like that, thinking about why having nuclear submarines is low discrimination while having nitric acid production is high discrimination, again, is something very counterintuitive.
Bradwell?
Okay. Yeah, no, I think so. I guess so. You'd like to see just a follow-up question. So you in particular, you thought the alpha and beta could that's where we could most benefit from having more discussion, sort of in those kind of discussions, or.
I think you have to do something to convince people that, even though you might be right on the statistical points, that it's better to have some kind of measure that takes account of uncertainty and that doesn't presume that things add up in just this way and are measured precisely and so on. I think that's good, but I think it's not enough. I think, I mean, as you guys plainly recognize in the paper, you also need to go back to some of the previous literature and say, okay, how would things change if you used our measure instead of a different one? And a couple of the things you point out is like, hey, our measure allows us to also look at difficulty and discrimination, and we get these surprising results, but you just mention the surprising results and then leave it. So if you could tell me something about, which countries are driving those results, or what's your suspicion about why those results actually occur. You could also think about doing something like taking the Joe and Gartsky paper or like the Sing and Wei paper and just saying these guys included in their regressions things that they thought should be in there because they were measures of underlying capability. What happens if we substitute or augment those regressions with our measure of latency? How do the results change? Like, what new do we learn about how other variables predict whether a state is going to have a weapons program or whether it's going to proliferate or not. Like, that sort of thing would be very valuable, and I think not a whole lot of additional effort, since these guys are all nice enough to put all the code online for you.
Right.
You mean like variables that are unrelated to capacity?
Yeah.
So like democracy?
Your claim is our measure of latency is both more accurate and gives you a more accurate picture of the precision of this measure than simply including a fixed index. So if that's true, then if we run your measure in regressions that people have used to study things like whether states get nuclear weapons, maybe some of the other results from those regressions would change because of the artificial precision of the indicators they used.
Yeah. Thanks.
Sure.
Matt.
So two pretty small things that I just wanted to throw out there. One, I wanted to maybe offer an analogy that might be useful for thinking about a potential response to some of the things I said at the outset about framing and being very clear about what you mean by nuclear capability. So as I read your paper, it seemed to me like what you guys are talking about would be analogous to using GDP to proxy for a country's military power, in the sense that if you do that, you're not measuring the number of tanks or the number of missiles a country actually has. You're measuring its broad economic capacity that could be brought to bear for military power, which seems more like what you guys are trying to do. By contrast, what Ben Koch and I were trying to do with our measure was more specific. We were trying to, rather than look at GDP to proxy for military power, we were trying to look at the tanks and the missiles. So it's just, in a way, I think we are trying to measure in some ways the same thing, but I think it's analytically distinct in some important respects. So maybe that analogy might be useful for thinking about how to draw a distinction between different ways of thinking about nuclear capacity or latency. The other small thing I just wanted to throw out is I would like to know more about what it means to be difficult. So particularly in the context of Table 1, like, what does it mean for possessing uranium to be difficult? That's not something you can do. It's, you can't make uranium. It exists naturally. So either you have it or you don't. So it's a minor point, just a language thing, but maybe be a little bit clearer about what difficulty means in the context of some of these things, because it's not just about technical capacity necessarily for all these obstacles.
Yeah, I agree. And I think to a certain extent the problem that you've identified with uranium and interpreting alpha is language. We get similar feedback, and so I think it was our tendency to sort of use the language that's in the educational testing literature of difficulty and discrimination, and that's not really that doesn't describe well what's going on here. So I don't know if the better option is to just call them alpha and beta and just sort of describe what they do in terms of the model, or think harder about what they're doing in terms of the process and how our estimate translates those two features of each activity into outcomes. So I think it's a very good point.
Any thoughts on that?
My inclination is always to think harder about what it's doing and explain it clearly.
Yeah, absolutely.
But
Yeah.
teach their own.
I like in general, I think you are writing this for an audience that's going to include some people who maybe only have the vaguest idea of IRT models. And so I think it's good to do as you do and have this running example of going back to intelligence testing and whether the question is difficult or not, and whether it discriminates high intelligence people from low intelligence people. I think Matt has a valid point. I think it's more a matter of being a little bit careful when you're talking about particular indicators. So,
Okay.
You're having uranium is difficult in the sense that it is not evenly distributed across the Earth's surface, and some countries are going to end up without it, and some countries end up with it.
Okay. Right, and so maybe a solution would be to just deal with each of them, with the interpretation of each more specifically, like you just said. I like that idea.
Yeah, I definitely think that if you revert to speaking about them as alpha and beta, eyes are going to glaze over.
Yeah, I think you're right.
Matt?
And just real quick, I think this relates to something we were talking about earlier about intentions versus capabilities.
Mm-hmm.
So if you think about something like submarines, a very small number of countries have built, especially a nuclear-powered sub. But there's surely lots of others that could if they cared about having that capability. So, I mean, that's really because it's not necessary. You can easily have a nuclear weapons program without a submarine.
Right.
And you can deliver with bombers or deliver with missiles. So I guess the broader point is that there's heterogeneity here among these indicators, particularly when it comes to the language that you guys are using about difficulty or what have you. So it's a small point, but I think clarity would just really help in that regard.
We're getting close to the end, so are there any final major points that the discussants would like to make before we start to wrap up? We have a few minutes. Yeah, Andrew.
Just a short one to say. I think, it seems to me there have been a lot of good suggestions for how to move the paper forward, but one of them that I think is really important, especially for the folks who are not themselves doing quantitative analysis of this area, nuclear politics, is to put a little effort into comparing the numbers your model puts out against what people think the high latency states are versus the low latency states. And as I suggested before, if you can gather the data that's out there on when qualitative experts have estimated how long is it going to be until this state has nuclear weapons, and see how well do your measures correlate with those? Do you see some pattern in the changes so that these analysts aren't taking account of something important they should? That both convinces people that what may seem like a statistical black box is producing reasonable answers, and also increases the value of what you're doing.
Thanks.
Anything else from our discussants?
I'll add one more thing, which is that Andrew's pointed out a number of useful ways you might validate your measure, right, by comparing it to existing measures, and you guys do some of that. But going back to what people were bringing up at the beginning, once you've sort of taken out these things that sort of indicate, that tell us everything we need to know, basically that you already have a nuclear weapon, etc., you could sort of give a couple of historical examples where you see sort of big movements up in the latency scale at the point at which we know, states in the past have developed nuclear weapons, or something like that. That might be useful as well.
Cool. Okay.
Yeah, Matt.
Yeah, I just want to say that I think that's really good advice, because what happens now, so I found myself gazing at your map for a really long time and noticing things like Uzbekistan and the Netherlands appear to be shaded the same color, suggesting that they have the same level of latency according to your measure, which seems odd to me. So to the extent you guys can kind of validate the measure through some of the things that by some of the means that Andrew and Danny and others are suggesting, I think that would be really helpful.
Great. Okay. With that, Brad and Will, do you have any last comments for our discussants or for our audience?
Just like to say thanks to everyone.
Yeah. Echo that. Yeah, this is really useful. Thanks.
Sure. Okay. Thank you very much to the authors for presenting a great paper. That was really interesting. And thank you to our discussants for taking the time to read it and participate in today's discussion. Anyone who's watching or who tuned in late, you can go back to the beginning and see the presentation that Will and Brad gave of their research so that you can get a 15-minute snapshot of what's going on in their paper. Or you can read the paper by going to the Peace Science website and looking under the Colloquia tab, where you can look under, and it's posted there and is also posted under archives. If you have any comments or questions, feel free to email the authors in order to give them as much feedback as possible, or you can leave a comment on the Google Plus page or the YouTube page, and I'll encourage the authors to check those out, because occasionally we do get comments, and you might get something useful. And our next presentation of the Online Peace Science Colloquium is going to be Henry Pascoe, who is at the University of Texas, and he'll be presenting a paper, Can Foreign Aid by Allies Against Terrorism? The Role of International Agreements. And that will be on April 29th at 10 o'clock Pacific time, which is the only reasonable Pacific time zone. So thanks again to everybody, and we'll see you all next time.